Today we're going to talk about properties of acids and bases. Common household things we use all the time. On the acid side, you'll see things like lemon juice and vitamin C. On the base side, a lot of cleansers plus baking soda. These are very common things and you've heard of them before. Acids have very special properties. They're used for a lot of things because of these special properties. What makes an acid so special? Well, an acid is special because it contains hydrogen ions. Those hydrogen ions give it very special properties. It allows them to do certain reactions. Those hydrogen ions will react with a lot of stuff. Now, those hydrogen ions are really released when it's placed in water. It means anything that's an acid, you place it in water, and that hydrogen gets released from the other ions and floats around, which means it can then react with things. And that's what makes it special. When we look at the types of things that are acids: vinegar, oranges, vitamin C, aspirin, and we use acids in things like car batteries and other types of batteries. These acids would all be sour if you tasted them, like vinegar, but we don't taste a lot of acids because they can also be very corrosive. Formula always begins with an H, or hydrogen, which makes sense. If it's going to release hydrogen ions in water, it has to have hydrogen in it. That's pretty logical. When we name them based on what's in them. Up until now, HCl we would have called hydrogen chloride, which is not technically wrong. It is a hydrogen ion attached to a chlorine ion, so hydrogen chloride. But because it's an acid and we want to recognize its special properties and the kinds of reactions it can do, we name it instead hydrochloric acid. If it's a metal and a nonmetal, it's always hydro followed by the nonmetal it's attached to, but with an ick at the end. When we deal with polyatomic ones, because hydrogen can happily attach to a polyatomic ion as well, we name them after the polyatomic ion. So sulfuric acid, when in our old naming system, we would have called it hydrogen sulfate. Still not wrong, hydrogen sulfate, it's just we want to recognize it as an acid. In bases, well, bases are bases because they contain hydroxide ions when they're released in water. When they're put in water, hydroxide ions are always released, float around, and then they're able to react. You'll notice I have put that part in red. Those are the definitions of an acid and a base. It's important to realize that, which is why I put them in red, so that it was really clear what the definition was. Examples, things like drain cleaner, soap, antacids like Tums or Rolaids, and baking soda. All of these, when placed in water, will release hydroxide ions. That's what makes them bases. Formulas can contain a few things. The big two things is either hydroxide ions, kind of obvious, you put them in water, they release hydroxide ions, but also bicarbonate, also known as hydrogen carbonate. When that's placed in water, they will also release hydrogen or hydroxide ions. So those hydroxide ions will show up. Names, well, they'll include hydroxide, bicarbonate, and even carbonate. All of those things placed in water will release hydroxide ions. They're named just like the polyatomics we've always done, right? Nothing special. We name them things like sodium bicarbonate, because it's sodium attached to bicarbonate, or sodium hydroxide, sodium attached to hydroxide. We already learned how to name bases when we learned the naming system for polyatomic ions. That doesn't change. Bases don't get special names. It's the common acids that do. They get those special names. So I've put these two charts in the note as well so that you can always reference back to them. We really don't use a lot of these in high school. We use a lot of hydrochloric acid because it's very easy to get a hold of, and we often use it in labs. The other one we'll use in labs is sulfuric acid. The rest of them,